Well, hello everyone and welcome back to Adrian's Digital Basement. This is another video in the Commodore 64 repair series. I have 12 of these machines. This is actually machine number 12 that I think all need repair. And in this video, we're going to troubleshoot and fix the second machine. I know I said that I might end up working on multiple machines in one video, but to make videos that are of a normal consumable length, I'm going to try not to cram too much into the video. So if they're interesting repairs and they're not super quick fixes, then it will be just one machine per video. But you know, sometimes the 64 repairs are like, oh, it's a bad PLA, you just pop a new one in and it's fixed. Well, that's kind of easy and kind of boring. So yeah, it's going to be the ones that are a little bit more involved than that. Anyhow, with the second machine, it's not working because I tested all of these and I know they're not working. So without further ado, let's get right to it. All right, here we are. This is machine number 2. We have a black screen, no power LED, it's probably disconnected, or maybe it's a bad power switch. This one may be a very boring fix. So yeah, the power switch is sort of flaky. Let's crack this open. This machine is heavier than the others. It's in a little bit rougher condition, and when it's heavier, usually means it has all the RF shielding inside. So there's the cardboard one. Interesting. There's a sticker here that says North Coast Programming, Willoughby, Ohio, with a phone number there. It says NCP and NCP here, but I assume that is North Coast Programming. I don't think that has anything to do with an error or anything like that. You know, I didn't even pay attention if the power LED was hooked up or not when I pulled it apart. It probably was, because this thing doesn't really look tampered with. So that most likely implies that the fact that there's no power LED means that the power switch is bad. All right, inside here, RF shield, bye-bye. Definitely water intrusion in here, piece of styrofoam. If we flip this over, yep, definitely some rustish damage or whatnot. Now, looking at this board, everything is soldered on. Date codes, 27 week of 84. This one is 85, the SID. Everything else is 84. It does not have the MT RAM, but it does have 2 MOS chips, 3 MOS chips. Bad sign right there with these. If these are bad, that causes all sorts of RAM issues. Like this will affect those parts of the RAM, and that's that part of the RAM. Those are like the multiplexers. Things in here look pretty unmolested, but I'm going to remove the RF shield just to double check. And I think, like I said, RF shield. Power switch is probably the problem here. I often just cut these off, but people got mad that I did that, so I'm gonna spend more time to desolder them. All right, it is desoldered. There's one more there that I can't get with the desoldered iron. It doesn't fit in that space. So that one I'm just going to have to break off. All right, let's take a look at the underside of the board. Typical hand soldering mess that's on these boards, but let's see what's happening over here on this section. Nothing, I'm gonna say. Everything here looks original. All of the leads are cut way down. They're barely sticking out of the board. Don't know why they cut them so much, because there are plenty of other leads that stick out a lot further than these, but that's what Commodore does sometimes. All right, let's hook up the power and let's hook up the video. Now, one easy way to tell that you're not getting power, of course, you can hook a multimeter up and check for yourself. The other way is definitely check for that vertical line on the output of the video. That would be on the far left side. That only happens, of course, if you have a working clock generator and a working VIC chip, but generally those don't fail. And if that's not working and the power LED is not working, yeah, it's a good chance you have a bad power switch. The fuse that's on the board right here, by the way, does not affect the 5-volt power rail, which is what the LED runs off of. This is only for the AC input, which gets rectified through this bridge rectifier and then turned to 5 and 12 volts to run, I think, the SID chip, the VIC chip, and maybe something else. I can't remember right now. But basically, you will not have a working 64 if that fuse is blown or removed or whatever. But you will have a power LED and you will have 5 volts on the RAM chips and stuff like that. That comes directly from your external power supply. All right, multimeter is ready. Let's see what we're getting from a voltage perspective. Well, I heard a pop, so we're getting something. Okay, so we're getting 12 volts. That implies that the AC input on this power switch is actually working. But there is video now. Okay, there's a line. I didn't even notice that on the screen. Okay, well, I think the power switch on this, when I first tested it, was very sticky feeling, but then after that initial testing, I turned it off and on a whole bunch of times, and that seemed to have freed it up a little bit. What I'm gonna do is I'm just gonna put a little Deoxit in there just to make sure that it's actually not all gummed up. Ultimately, it should be replaced. I personally don't have a replacement supply of those switches. I sort of salvaged them off old dead motherboards, and I don't really have any dead motherboards because I always seem to be able to fix them. If anyone knows the exact right switch for me to buy, put a link down below in the comment section so I can just order and have some on hand, because that's definitely a failure point on 64 sometimes. All right, so we saw this thing is now powering up, but it's got a black screen. So what we need to do is I'm just gonna plug in the power and the video again, and we're gonna scope some signals, see what we can see. Okay, so here's the 6510. We're looking for a VCC on pin 6. The oscilloscope is up. I have the probe. Let's turn this on, and there we go, we're getting 5 volts. Okay, that looks good. Let's go to pin 1, the clock in pin. There we go, let's turn that on. That looks good. Let's zoom in quite a bit. There it is, 1.02 whatever megahertz. That's close enough. So we have a good clock. It looks good too. Okay, the last pin to check is pin 40 here, which of course is the reset pin, which should be low and then go high when I power this on. There we go, that's normal operation right there. All right, so we validated that the reset line is good, the clock is good, and the 5 volts is good. That is enough to get a running machine. You of course need the 12 volts if you want to have like a working sound and video, but we can at least see the machine executing code or not if the CPU is good and the RAM is good and stuff like that. All right, so next up, let's check these data lines. So pin 37 here. So we're on data line 0. That looks good. That looks like normal operation, I'd say. We're at 1 volts per division, 4.2 volts, but that's not necessarily a problem. And let's just look through all the other lines on here. So that's 1, 2, 3. That looks a little weird, but nothing, right off the bat. That's 4, 5 looks normal, 6 looks normal, and that's the last one, 7, and that looks totally fine as well. Let's just jump right here and check an address line. There's some address line activity, and yeah, that seems normal. 1, 2, 3, 4, 5. Yeah, I'm just gonna power cycle the machine here. Yeah, see, there's some activity going on there, but I don't think we have a working machine. Let's scope some of the lines on the PLA chip. The PLA chip is like the traffic cop on the 64. It basically selects which chip should be active at any given time. If the outputs on the PLA are bad, like say one of the outputs is stuck low, what's gonna happen is it's gonna keep one of the other chips selected all the time. So for instance, if the line that goes to the character generator is always low, because the output is stuck low, the character generator ROM is just gonna be on all the time, which will immediately create a bus conflict. Now, I didn't necessarily see a data bus conflict happening when we looked at the data bus lines, because you can kind of see that sometimes where like stuff is in the middle, where like there's a high and a low conflicting. But sometimes what happens is one chip is trying to drive it high, and the chip that's stuck on can drive it low, and TTL logic, when it drives it low, is very strong and kind of overrides the high signal coming out of the other chip. One thing I can do is I can just feel some of these chips here, not the PLA, but like the ROM chips or these 6526s here, just to see if anything is extraordinarily hot. Nah, nothing actually seems extra hot. All the chips feel normal. Let's just take a look at some of the outputs on the PLA though. So we're starting right here on pin 6, which is the character generator. That's high. We're just going through these pins on here, the output pins, and we're looking for anything that's low, that's stuck low. And so far, we're okay. So I did the character generator, high RAM, low RAM. This is CAS, which should be pulsing, so that's normal. We are on ROM high, ROM low. We're on IO, that's totally normal. We're on GR/W, that looks fine. Over on this side, we have character ROM, that's pulsing, so that's normal. Kernel ROM is pulsing, that's totally normal. Basic, it's not doing anything. It's probably not running basic right now. It's just frozen. CAS RAM is pulsing, totally good, that looks normal. And I think the rest of these pins right here are all inputs, so I'm not gonna even check those. Okay, so the PLA appears to be fine actually. But back here on the video signal, we are still just getting the line, so black screen for sure. Okay, I think what I'm gonna do here, I'm just gonna remove the SID chip. It's always good to remove any socketed chip, especially like the SID chip. That's not necessary for the machine to run, but a bad SID chip can actually take the computer down. I don't think that's what's happening here because it would take it down with a bus conflict. Essentially, a bus conflict could happen on the SID if it is not being told to turn on by the PLA and yet is still trying to drive the bus. That could cause a bus conflict. When we looked at the data bus lines on the CPU, they looked normal, and I don't think there's a problem from the SID, but it doesn't hurt to take it out. Only takes a second, so might as well do it. Okay, so I just turned on the computer again after that, and now it's got a bit of kind of garbage on the screen, and if we power cycle it, it may not come back. It did not. Oh, it did come back. Interesting. So that started happening when I removed the SID. Let's just see if it's consistent. It might have been happening before and I just didn't notice it. Does seem to happen every time. What I suspect is the problem here are these multiplexers here, these MOS multiplexers. These are super unreliable. Whenever I see these, I always suspect that those are the problem. Just for fun, let's try the dead test out on this machine. Let's see if this is gonna do anything. Okay, it's giving us flashing. That's not helpful, whatever. I don't believe there's bad RAM. I believe there's bad multiplexers. Let's try the other side of this cartridge. See if this does anything at all. Ah, look, it's trying to run here. It is trying to run. It's actually running too. So you can kind of see what's happening is like parts of the text is going to the wrong place. It's not clearing the screen properly. The color RAM is working fine, but that's addressed separately. And the VIC2 chip talks directly to the color RAM. So that's fine because you can see those boxes there. And we can see the character ROM is working as well because we see some functional letters, but it's just all not working properly. These two MOS chips, which I've gone ahead and drawn a mark on, are these 74LS257s. They are tri-state quad 2 data selector multiplexers. And now that we have the pinout, why don't we actually try to scope some of the outputs on these and just see what we see exactly. All right, I'm on pin 4, which is output Y1. All right, so we're actually getting an output here. And whether that looks good or not, I don't know. I don't remember what the failure modes of these look like when they're not working. Let's check the other outputs. So that's how pin 7 looks, which looks fine. Let's check this other one here. Pin 4, it looks okay, doesn't it? Pin 7, that looks okay as well. And then here's the other output, that's pin 9 and pin 12, which looks okay. And on this other chip, pin 9 and pin 12. All of that on the scope looks totally fine. I completely suspect that these chips are still the problem. Let's take a look at the schematics to look at what chips do what on the 64. So the two 257, which are the muxes, these two MOS chips, which I suspected were bad, but look good on the scope. These actually control the addressing that goes from the processor to the RAM chips. And that's because these 8 RAM chips here require a bit of multiplexing because they have row and column addressing. So you need muxes for that to work. Now I think if those chips were bad, or one of them were bad, we would not have functional diagnostics, which clearly we're getting. All right, take back what I said about the diagnostic actually fully working because it seems to stop on RAM test 2. Typically with this diagnostic, what happens is if it goes through a full cycle, you hear the SID music, which I put the SID back in and I'm not hearing anything. Could be a bad SID chip. But what happens is after it tests everything, it restarts and it will clear the screen and redraw RAM test 1, RAM test 2, and stuff like that. Well, it's not doing that. It just sort of stops where it is here. So I'm assuming it's actually failing the RAM test. And that really does lead me to believe that these multiplexers are the problem. And because we're getting text in memory in the wrong places, I have a feeling the CPU as it writes to RAM is just getting written into the wrong parts of memory and probably it's overwriting other parts of memory. And really, I think this is going to be a failure of those multiplexers. So I'm going to make a guess here because of history of knowing that those MOS chips are unreliable. And I'm going to pop them out of the board and let's put in some replacements. All right, both MOS chips have been taken out. Sockets are in. I have a 74 LS257 here. I couldn't find another one, so it's a 74F257, fast. It may be too fast, so let's just see what happens. No cartridge. Let's turn this on. Look at that. 2,152 bytes free, so it's acting like there's a RAM problem, but we're getting a good screen. No more stuff in the wrong spot. Let's try the diagnostic cartridge here. See if it's going to detect any kind of RAM problems now. Actual RAM problems. Look, no more corruption there either. So definitely these are bad. We'll test them in the Retro Chip Tester Pro in a second. Okay, RAM test 1, bad, is coming up now. Well, there could be bad RAM, but the other problem is that fast chip, this one right here, this could be causing the issues. All right, I looked through my chips again and I found an LS257. So I now have 2 that I put in this board. So the F chip, which I think is this one, is out. 257 is in. What do we get? Oh, look at that. It freaking works. 38,911 bytes free. Yes. So that is interesting. The fast chip was too fast and caused, I guess, RAM errors, like it would write to the wrong place when the CPU was trying to write to specific areas. You know, who knows what was happening. It was too quick. You gotta use the LS part. All right, let's put the diagnostic in. Let it run through the full thing. You know, let's go for broke and plug in this diagnostic test harness while we're at it. These edge connectors are looking mighty crusty. Okay, everything's connected. Let's turn this on. I think the connectors are pretty stiff here, so they scratch through the corrosion. Let's see. Do we have a fully working machine? I put the SID back in as well, so we might hear those tones. Here we go, RAM test 1. Yes, that passed, which didn't before. Oh yeah, RAM test 2 passed as well. So let's just let this run through the rest and hope for the best. It says user port bad. Okay, so the SID is working. Turn that down. We're getting cassette bad, control port bad, user port bad. This could all be bad connections on here, so let me try to clean those first. Okay, a little 99% IPA, a little polishing, and a little deoxit. Let's see if it's any better now. Okay, well, it got a little bit better. I still think it's like a bad connection on here. Let's let it run through one more time. I just moved this connector on the user port just slightly. And let's let it run through again. It's probably gonna start working. And the control port error, I think something might be wrong with my harness. It seems to be doing that now on every machine, even if the control ports are working perfectly. Okay, there we go. Everything is testing good except for control port, which I said always seems to test bad now. Sweet, okay, so at least from a diagnostic perspective, this machine is totally fixed. It was just those 2 MUX chips. So that leaves us with running actual program code on here. All right, easy flash is in, joystick is connected. Let's turn this on. What do we have? Oh, that I always get it in the wrong port. Either that or the joystick ports are dead on this thing. I doubt that still. Nope, it's working. Oops. We go to Adrian's tools. We go to 8-Bit Dance Party. Let's just listen to the SID chip here. Turn up the volume. Alrighty, that is a fully functional SID chip, which means this is a fully functional C64. 2 bad MOS chips. So, moral of the story, suspect bad MOS chips. And you know what? Both were bad. And let me get the Retro Chip Tester Pro and let's validate that. Okay, we're on the right profile here. See if these chips actually make it into these sockets. No, they really don't. The legs are just too short. I am not sure that these are actually testable. I'm gonna hold it down. Well, it said failed, but to be honest, oh no, that's actually in there. Okay. Okay, good. So yeah, there it is, failed. What's all this saying? Trying to decipher this. I don't know. It says there's a problem. Let's check the other one here. I'm gonna hold it down, latch that. Test. That didn't actually go in, because look, if I test it without the chip in there, that's how it reads, all zeros. No, this one will not go in that socket. Anyways, they were both soldered into the motherboard, and it was not working. We saw it. And after I replaced them, it now works perfectly. So clearly, those were the problem. So there we have it. Machine number 2 is now good. It had just bad U13 and bad U25. I'm pretty sure the power switch was bad originally, but I just toggled it on and off a bunch of times, and now it works. So yeah, that problem was alleviated by just exercising it. So there we have it, the repair of the second Commodore 64 with those bad MOS logic chips. Those things are absolutely terrible, and it was in the first machine that also had a couple of those chips which were still working, but I had mentioned for future-proofing that first machine, it'd probably be a good idea to remove all the empty RAM chips and also the MOS logic chips. Now in this machine, as you just saw, it was the 2 multiplexers. So that number 1 machine, the MOS chips that were in there, the MOS logic chips, they were not the multiplexers. It had actual Fairchild ones in there, which is probably why they were still working. It seems that it's those multiplexers that are especially unreliable in these machines, the MOS ones, that is. Now, a few viewers have asked me to create like a database of 64 repairs with like the symptoms and pictures and what the fix was and stuff like that. Unfortunately, I just don't have time to keep that kind of a thing up to date. But the one thing that my viewers might be able to help with is all my previous 64 repair videos are of course on the channel, and I don't generally repair them off camera. I mean, there have been a few years ago that I had done, but more recently, it's always gonna be on camera. So if someone wants to kind of go through the videos and watch them and screen capture what the symptom was on the output of the 64, and maybe create like a Google spreadsheet that shows the picture and has the fix and the symptoms and stuff like that, that could be helpful to the greater community. I don't really think that I've ever encountered like 64 faults that are unprecedented or no one has ever seen before, because pretty much everything has always been seen before, because so many of these machines have been sold and used over the years that pretty much every problem that could happen on these has happened on these. So anyhow, I hope you enjoyed this repair. If you did, thumbs up would be appreciated. If you want to become a patron, there's a link in the description below. My patrons' names are scrolling up the side of the screen. It was really cool. I asked my patrons if I should fix these machines, and that is one of the perks of the higher up tiers on my Patreon page or whatever, that I will post behind the scenes content and other interesting little tidbits and stuff like that for them. So Patreon allows you to be a little bit behind the scenes of Adrian's Digital Basement. So anyhow, comment down below, second channel, subscribe, all that usual stuff, and that's gonna be that. So stay healthy, stay safe, and I will see you next time. Bye.